Sometimes you'll need to solve equations that involve trigonometric ratios like sine, cosine, or tangent. When solving these types of equations, there are two important things to keep in mind throughout. The first thing is you need to isolate the trig function first, and the second thing is don't forget the cast rule. You'll see why as we work through some examples. As we work through these examples, we're going to be solving for values of theta that are between 0 and 360 degrees. Remember, the angles start on the positive x-axis and work upwards going counterclockwise. This first example is 6 times the cosine of theta equals 3 times the square root of 3. We need to isolate the trig function, so we're going to isolate cosine of theta. In order to do that, I'm going to divide both sides by 6. And that will leave me with the cosine of theta equal to 3 times the square root of 3 divided by 6. To get theta by itself, I need to take the inverse cosine of both sides. And when I do that in my calculator, I get an answer of 30 degrees. Now this is where it's very important not to forget the cast rule. In this line up here, we see that the cosine is positive. If you remember the cast rule, you'll remember that cosine is positive in quadrant 1 and in quadrant 4. So you can see there are going to be two possible answers for our angle. There's an angle in the first quadrant. There's also an angle all the way around into the fourth quadrant. So this answer of 30 degrees that we got refers to the space between the x-axis and the terminal arm. So what I mean is this space is 30 degrees and this space is 30 degrees. So this first angle, I'll call it theta 1, is equal to 0 plus 30 degrees. So it's just 30 degrees. Whereas this angle over here, which I'll call theta 2, it equals 360 degrees minus 30. Which means it's equal to 330 degrees. And this makes sense because we can see in quadrant 4 the angles have to be between 270 degrees and 360 degrees. So now that we've looked at the cast rule for this, we can see that theta is actually equal to two possible answers. It can be 30 degrees or it can be 330 degrees. Those are our two possible answers for theta. Here's another example where we're solving for theta. First we have to isolate sine theta. So the first step is going to be to subtract 4 from each side. So I'm left with sine theta equals 2. And if I take the inverse sine of that, my calculator says math error, which simply means there's no way you can get an answer for this. There are no angles between 0 and 360 degrees that will give a sine of 2. So there's no solutions. Here we have the negative cosine of theta equals 0. So to isolate the cosine of theta, I have to divide both sides by -1. So the cosine of theta equals 0. If I take the inverse cosine of that, I get an answer of 90 degrees. But wait, don't forget the cast rule. Remember, this value of 90 degrees here means that there's a space of 90 degrees between the x-axis and the terminal arm. So that means we have a terminal arm here, because there's 90 degrees between the x-axis and the terminal arm. But we get the same result if the terminal arm is down here. So our second angle would be this one. I'll call that theta 2. So you can see that theta is equal to two answers. We have 90 degrees. We also have 270 degrees. This example looks more complicated, but the process is exactly the same. We're going to subtract 1 from each side to isolate tan theta. And if I type that into my calculator, I get this. To get theta by itself, I take the inverse tangent. And when I type that into my calculator, I get an answer of negative 30 degrees. So let's figure out what this means. Up here, we see that tan is negative. So that means tangent is in this quadrant or this quadrant, according to the cast rule. Now this line here, theta is negative 30 degrees. That means we're going the opposite direction. So we're going down 30 degrees. That's negative 30 degrees up there. So our two angles are here. I'll call that theta 1. And then we also have the angle that goes all the way around into the fourth quadrant. I'll call that theta 2. So remember, the space between the x-axis and the terminal arm is 30 degrees. That means what I've drawn as theta 1 is 180 minus 30 degrees. So that's 150 degrees. Makes sense? It's between 90 and 180 degrees. Theta 2, well, that's just 360 degrees minus 30 degrees. So it's 330 degrees. So our two answers for theta in this case are 150 degrees and 330 degrees. Here's an equation. I divide by 2 on both sides to isolate for sine theta. And I notice sine is negative, which means my answer is going to be in quadrant 3 and quadrant 4. Theta 1 and theta 2. When I take the inverse sine, I get theta is negative 57 degrees. This means the space between the x-axis and the terminal arm is 57 degrees. So that means what I've labeled as theta 1 is 57 degrees more than 180. And what I've labeled as theta 2 is 57 degrees less than 360 degrees. So my two answers for theta are 237 degrees and 303 degrees. And my last example to show you is this one. I do the same thing as before. I need to isolate the tangent, take the inverse tangent, and I'm left with 66 degrees. I notice the tangent is negative, so that means I have my two answers, one in quadrant 2 and the other one in quadrant 4. What I've labeled as theta 1 is 66 degrees less than 180, and what I've labeled as theta 2 is 66 degrees less than 360. So my two answers for theta are 114 degrees and 294 degrees. So just remember, any equation that you're asked to solve that has a trig function in it, like sine, cosine, or tangent, you need to isolate the trig function first, and then when you're solving, don't just go with the one answer your calculator gives. You have to remember the cast rule, because there's often more than one answer.